Q&A. Barbara is an architect specialized in urban and territorial planning with a master's degree in city management from the University of Belgrano, Buenos Aires, Argentina. She has a master's of science in GIS and is currently pursuing a doctoral degree in city, territorial, and sustainable planning at the University of Tarragona in Spain. Since 2021, she coordinates the Central American Caribbean hub of UNID-GIS, Latin America network of universities based in Panama City. Barbara also works part-time for Esri Panama, advising governments on land administration, urban planning, and GIS. It's a real pleasure to have you join us, and thanks once again for joining at the last minute.
Thank you, Tim. Bueno, buenas tardes a todos.
Good afternoon, everyone, and thank you very much for staying to the very end. What I'm going to show you is an exercise, a use case that was implemented in a very small municipality in the north of Buenos Aires province in Argentina, to be able to show you the functioning of tools, of AI tools connected to GIS to have a reference. Collection and issues at a municipality is to use this for transparency purposes and also to be able to have effective results in the short term that can have an impact. Understanding that in the case of this municipality, there was a sparse data with respect to appraisal, and there is a difference of 80% between market values and what the values that the municipality had. So to kick off, take into account that the valuation office, when we work in keys, this allows the work in critical aspects. We have a system of registry where we have the information that we integrate, and in this municipality, the GIS systems were being adopted in other areas, and part of this information, well, we were able to use it. We also have a knowledge system. This is the system where we have the people who work in the valuation office. They work in analysis of these geographical systems, and then a system of engagement, sharing data, etc. And what we're showing you here is a typical workflow of AI with the GIS system. We call this GeoAI. And we have a reference such as a satellite image or previous information. And in the case of the appraising or assessing, it was the parcel that we had in the municipality. This was existing information. Normally, when we have this first inclusion of information, we do labeling of the elements that we want to predict. We prepare the data, we clean it, we organize it, and then we begin to think about the variables to be able to train the predictive model, which can generate as many inferences that are necessary to be able to have the best and most precise results.
This process is assisted by AI, and it allows us to integrate future analysis steps and obviously also connect with applications and dashboards, as it was shown at the beginning of the session. In the case specifically of this exercise that I am talking about, we worked on 4 main steps. The first one, or for the first one, we used a system known as web scraping, using market data. This system, what it does is to automatically consume the information that has been published in the main portals that are used to buy and sell buildings, and we need to understand how to integrate this information in the platform where we will add other layers of information. In order to be able to do that exploratory analysis of the variables, in the case of my municipality, we worked with a team that assessed what were the different layers that could bring more sense to the building. And what do I mean by this? To add layers that have to do with, for example, with proximity to hospitals, schools, to public transportation, if there were hubs, if there were hub centers or transfer centers with rail, bus stations, but also a negative impact for the valuation could be critical areas that were vulnerable to floods or areas that had some sort of level of insecurity identified by the systems that were working on the municipality, using, for example, camera information from cameras and also socioeconomic data. Once the variables were chosen in terms of positive and negative impact, and once the previous information had been loaded, we started the training part, and also we started adjusting everything. We decided to use machine learning assisted models, and the weighted value on the building is automatically decided by the system. Therefore, the human decides what are the different layers, but then the value is decided by the system automatically. The interactions are as many as necessary until we have a final result, which is a predictive map. So after training and implementing it, we worked on other stages. So after talking about the training and implementation, I will address the other stages. Web scraping. This information is usually dirty and has to be cleaned, and it has to be organized. We have to structure the raw data. We need to work with more precise GIS information. Sometimes they provide proximity, but they don't give you certain information about the exact location of the building. And then we had to remove all the ambiguous data. For example, in the municipality that we were working on, was the one where the presidential residence was located. And of course, we need to remove this house from the sample because we cannot assess its value. So being close to that space has an impact, but not the value of the building itself or the property. Then we move on to the next step, which is the local data set analysis and geoprocess. So after cleaning the information and so on and so forth, we decided that it was important to understand the distance between the different elements in the layers and the buildings that we wanted to appraise. So we worked with the multiple clustering tool. We want a multiple variable clustering tool to have much more accurate information. In the municipality, we identified 13 clusters that were defined by price, location, and proximity to commercial areas, accessibility to two important nodes or hubs, 2 train stations, and the urban structure defined by 2 main local avenues. The application of the web scraping and the clustering are within those automated tools that are included in the platform that was used. And then the third step, prediction. Here is where we see how the process takes place automatically, and it takes into account the layers that we had already loaded into the system. It takes into account the impact of the weighting of the clustered areas and how everything is compared to the information, complete information that was also loaded into the system, the commercial site. So we started the exercise with 1,000 households from this commercial website, and then after a first step, we increased it to 10,000. So we also updated and eliminated some of the variables that in the beginning seemed like they were going to have quite an impact on the valuation, and then we decided that they were not so important. We realized that the surface of the building was, or the area was very important, of the plot or the building. This is the last step where the mass evaluation is developed, and here's where we can clearly see darker areas in a darker red. It's basically on the coastal municipalities of northern Buenos Aires. Basically, the front line has a higher value, and here is where we also have more commercial activity. That strip that is more or less 600 meters long is the typical buffer that we take into account in terms of urban planning, which is a new strip for public transportation. And precisely in those years, the metro bus system was implemented in this part of the city that has concentrated stations where the value of the buildings is higher. Then we see that the color gets lighter and lighter as we move inland and towards the highway that is the boundary between the city of Buenos Aires and other provinces. And where we have darker shades is where we have train stations. So we see there is a correlation. And when we start adding other significant layers, for example, flood areas, and that the value of the building goes down in these areas, or where we have indicators of crime that may be high, that also decreases the value of the property. So basically, the reason why we try this type of tool is because we try to increase accuracy, efficiency, but also automation, so that everything is much faster. If we did everything manual, if we had done everything manually, it would have taken us at least 2 years. And when we talk about resources, we also talk about human resources. At the time in that office, we didn't have a lot of people. Many of you may wonder why the prediction is assertive and is accurate. Well, the model has a percentage of the commercial sample that is there in reference to and compared to the prediction value. And with that value, the Secretary of Tax Revenues in the municipality sees which one is that error margin admissible, which is much more beneficial than the 80% of real sparse values that we saw. So adding this GIS information was very important, and it's a much simpler task than other things. It allowed us to, it allows us to scale this mass appraisal in the future. It's more objective and consistent. The valuations are more objective and consistent, and it also allows us to have a more dynamic market monitoring. Thank you.
Final presentation, and one of the things I just wanted to call out from Barbara's presentation is that the example from San Vicente was one could argue a data poor environment. There wasn't a lot of data to rely upon to calculate property values, but The team was able to put together a data strategy and an innovative set of strategies and methodologies to go about collecting, creating data sets that allowed them to then conduct essentially a mass valuation across the municipality. So again, leveraging new technologies, new methodologies are definitely opportunities to take work that previously maybe would have taken years to conduct down to several months. So just another great example. So we're done.